Hello everyone, myself Vinay Kumaram. I'm pursuing PhD in physics. So in this particular YouTube channel, I'll be teaching physics, chemistry and mathematics starting from 8th standard till 12th standard. So if you want to learn physics, chemistry and mathematics, then please do subscribe to my channel. So now we have compared kinetic energy and work done. So now how to compare potential energy with work done? So in order to do that, we should understand what we mean by potential energy. So what is potential energy? So in the word potential energy only you have a particular word, that is potential. So how much amount of energy stored in a particular object can be known as its potential in order to possess that much amount of energy. So that's why we call this kind of stored energy as potential energy. Always remember, potential energy is the stored energy. In the previous example, I gave an example of fuel burning and car running. So that means here when car was in motion, that car has certain amount of kinetic energy. Where did that kinetic energy come from? Because energy can neither be created nor be destroyed. I'll come to that part later when we are discussing about law of conservation of energy. So always remember, energy can neither be created nor be destroyed. So one form of energy should be transferred to other form of energy. Here car is having certain amount of kinetic energy means that particular kinetic energy is coming into the picture because fuel is burning. So that means this fuel initially carried certain amount of energy. So when fuel is burnt, that energy is released and that energy is getting converted to kinetic energy. So that means this particular fuel has certain amount of potential energy, and when that potential energy is extracted properly, then that can be easily converted to kinetic energy. So then that car can get the necessary amount of kinetic energy when it is in motion. So that means here stored amount of energy can be known as potential energy. Because here you are using a chemical compound as fuel, hence this kind of potential energy which is stored in fuel is known as chemical potential energy. Potential energy which is stored in fuel can be known as chemical potential energy, and this particular chemical potential energy is converted into the kinetic energy when car is moving. When car comes into motion, that means chemical potential energy of a particular fuel is getting converted to the kinetic energy of that particular car. So now what do you mean by potential energy? Potential energy is nothing but the stored energy which is capable of doing work, or work has been done on that particular object to gain potential energy. What is this? I am telling something different, right? Work has been done to create potential energy. So work done, already work has done, and this work done as potential energy. How is this possible? So now for example, you have a building like this, and on this building there is a overhead tank. So on this building there is a overhead tank like this. This particular overhead tank has certain amount of water in it, and there is pipe connected to the down part, and there is a tap at the bottom part like this. So now you can see whenever you switch on this particular tap, water starts flowing from the overhead tank. But now if you want to store the water in overhead tank, then you should do certain amount of work. So that means here already stored water inside overhead tank can be easily flown to the ground without any external effort. But if you want to take this water to that overhead tank, so let's say now this is another building where overhead tank is there, but this particular tank is empty. So let's assume this particular tank is empty and certain amount of water is there in a well on ground like this. So this water should be brought into this particular overhead tank. So that means you have to do certain amount of work in order to bring that water from ground to the overhead tank. So against the gravity you have to do the work. So here against gravity you have to do work in this particular case. So against gravity you have to bring this particular water to this particular overhead tank. So you put some pump into this tank and this pump pumps the water to overhead tank. That means here pump is doing certain amount of work. So that means here force is applied by pump and there is displacement of water from ground to the overhead tank. So that means here work is done by this particular pump. So that means work done is happening and that work done will convert to the potential energy of water. So now this water gains certain amount of potential energy and this particular potential energy can be known as gravitational potential energy. Why we call this as gravitational potential energy is because so we have done the work against gravitational force and this particular gravitational force will be responsible to bring the water down to the ground when the tap is on. So when we switch on the tap, the water flows from over a tank through the tap to the ground. So that means here gravitational force is responsible in bringing that particular water down. So that means the amount of energy at a certain height will be responsible for the gravitational potential energy of that particular object which is kept on that particular height. Not only water, any object, for example if there is a block like this and if you bring this block to a certain height, so let's say there was a block on ground and you have brought this block to a certain height h. So let us call this height as h. To this particular position if you are bringing this block, that means you have done certain amount of work in order to take that block to that particular height. So here you are bringing this particular object to this particular position. That means this much amount of height is there between this object and the ground. So that much high the object has been brought, that is h. Now let us write equation for work done. So work done's equation is force into displacement. So force is nothing but mass times acceleration into displacement. So what is acceleration in this particular case? You are doing work done. See, you are bringing this particular object from ground to this particular height. That means you are putting certain amount of force. For example, if this phone is there, I am bringing this phone from this particular position to this particular position. That means here I am applying certain amount of force on this phone against gravitational force in order to bring this phone to this particular height. So against gravitational force I am putting certain amount of force to bring this particular phone to this height. That means I am doing some displacement of this phone. So in order to do this displacement I am putting certain amount of force. So that is giving rise to work done. So that means work is done in order to bring this phone from this particular position to this particular position. So that means here also in this case, to bring this object from this position to this position, I am doing or a person is doing certain amount of work to bring that object to that particular height. So here because this work is done against the gravitational force, acceleration due to gravity will be acting upon this particular block, this particular object. So that's why in the place of acceleration I can write acceleration due to gravity g. So mgs. So what is s? S is the displacement. In this case s is the height at which that particular object is kept from the ground. So in the place of s I can write h. So w is equal to mgh and the work done to bring, so work done to bring object to certain height. So work done to bring object to a certain height on the ground. So work done to bring object to a certain height on the ground will be converted or is equal to the potential energy, is equal to the potential energy. So that's why work done in order to bring that particular object to that height is equal to potential energy. Here we calculated work done is equal to mgh. If we call this as equation 1, from equation 1 we are getting work done as mgh, and here work is done which is stored as potential energy. So work done is equal to potential energy. Here work done is equal to mgh. So that means here potential energy is equal to mass times acceleration due to gravity into h. That is the height. So potential energy is equal to mgh, and kinetic energy is equal to half mv square. So always remember, potential energy is equal to mgh and kinetic energy is equal to half mv square. And always remember one more thing, energy is conserved. So what do you mean by energy is conserved? So this is actually governed by law of conservation of energy. So there is a particular law, that is law of conservation of energy. What do you mean by law of conservation of energy? Law of conservation of energy simply tells you about the conservation of energy. That means here energy is conserved. So what do you mean by energy is conserved? Whatever amount of energy you are experiencing, that energy has come from any other form of energy. For example, in your house, there is a bulb in your house and this particular bulb is glowing. That means this particular bulb, when it is switched on, light is coming out from this bulb. So that means here light energy is there. Where did this light energy came from? This particular light energy is coming from electrical energy. So that means here electrical energy, this is just an example which I am giving to make you understand about law of conservation of energy. So electrical energy is responsible for light energy which you are experiencing in your house. And also when you switch on the fan, electrical energy is converting into the mechanical energy. Now if you consider one more example, you have gas stoves in your house, in your kitchen. So when the gas is burnt, you can see the flame and also you can experience the heat. So that means here heat energy and light energy is produced by burning the fuel which is stored in your LPG cylinder. So that fuel is chemical potential energy which is converting as light and heat energy. Using that heat energy you are cooking your food. That means any form of energy, even when you are traveling in your vehicle, you are actually converting fuel's energy into the mechanical energy of that particular vehicle. And also in your day-to-day life, whatever work you are doing, you are using your physical strength. That means you are using the energy which is there in your body. Where are you getting that energy? You are getting that energy from food what you are eating. And where does that particular food has got energy? That food has got energy because of photosynthesis of plants. How did photosynthesis happen in plants? So because of light energy, photosynthesis happens in plants, and that particular photosynthesis is responsible in producing fruits or vegetables in that particular plant. That means here energy is getting stored in the form of fruits and vegetables, and if you are eating that particular fruits and vegetables in order to get energy within your body, and using that energy you are doing your day-to-day work. So always remember, whenever you are experiencing or whenever you are noticing certain amount of energy, then there is certain another form of energy which is getting converted to that particular form of energy. So that means energy can be converted from one form to other form. So here energy can be converted from one form to other form. In this example only you can say electrical energy is converting into light energy. So energy can be converted from one form to other form, but it cannot be newly created or it cannot be destroyed as well. So energy can never be destroyed, never be created. Already energy is there. So from one form of energy you are converting that to other form of energy in order to do certain amount of work. So that's why here in law of conservation of energy you should understand that energy can neither be created nor be destroyed, but it can be converted from one form to other form. There is one more last concept in this particular chapter, that is rate of doing work. So what do you mean by rate of doing work? So here you have certain amount of energy. Using that energy you are doing certain amount of work. So energy is nothing but how much amount of work a particular object or a person can do. So here that particular work which is being done, how much amount of time a particular object or a person is taking will give rise to the power. So what do you mean by power? Power is nothing but rate of doing work. So rate of doing work is known as power. So for example, to understand power, we will take two persons. So one person is very much stronger. He is very much stronger, and the other person is not as strong as this particular person. So let's say this is one person who is very strong, and there is one more person who is not very strong, but he has certain amount of energy in him. So here this particular person 1 also has certain energy and person 2 also has certain energy. But here this person has more power compared to this particular person, and this person has less power. How we are defining this particular power? This power is determined by rate of doing work. For example, if I give a particular work for these two people, so if I give certain amount of work to be done by these two person, if person 1 takes 10 seconds to complete this work, and if person 2 takes 20 seconds to complete this work, so the same amount of work, this person 1 is taking 10 seconds and this person 2 is taking 20 seconds. So that means here same amount of work is done. That means same amount of energy is spent in order to do that work. But here person 1 is taking 10 seconds to do that and person 2 is taking 20 seconds to do that. So as we know, rate of doing work is power. So power is denoted as work done in certain amount of time. So we were telling the rate of change of displacement as the velocity. So that means here how much displacement happens in a certain amount of time gives you velocity. Similarly, how much amount of work is done in a given time gives you power. So in this particular example, person 1 is taking less time and person 2 is taking more time. So that means here P is equal to person 1 is taking more time, means here time is in the denominator, and in person 2's case, so let's call this as time T1, and in person 2's case, so person 2 is taking more time to do the same amount of work. So work is same but time is different. Person 1 is taking 10 seconds and person 2 is taking 20 seconds. Or in general, T1 is less than T2. So T2 is 20 seconds and T1 is 10 seconds. That is, T2 is the time taken by person 2 and T1 is time taken by person 1. So that means here person 1 is taking less time than person 2. Here, since T1 is less than T2, in denominator we have this time. So that means any value in the denominator, if it reduces, then the overall value increases. So that means here time T is less, so power is more. In this case time T2 is more, hence power is less. Here both the persons have done the same amount of work. They have spent same amount of energy in doing a particular work. But person 1 has taken less time and person 2 has taken more time. So that means here this particular person 1 has more power and person 2 has less power. That is what I have written here. More power and less power. So what might be the SI unit of this particular power? So we'll discuss about SI unit of power. So power is equal to work done by time. So what is the SI unit of work? Work's SI unit is joule and time's SI unit is second. So joule per second is the SI unit of power, or joule per second can be known as watt. So either you should use small w and expand the full form, that is watt, or you can simply use the capital W and don't expand the full form. So watt is the SI unit of power, or joule per second is the SI unit of power. Now if you want to define what you mean by watt, then 1 watt of power is 1 joule of work done. So 1 joule of work done in 1 second. So 1 joule of work done in 1 second is 1 watt power, because when you take 1 joule in numerator and 1 second in denominator, then the answer will be 1 joule per second, that is nothing but 1 watt. So that's why here 1 watt of power is 1 joule of work done in 1 second. So this is the definition of 1 watt of power. So now you have better understanding about work, energy and power in this particular chapter. This is all there in this particular video. Like this, if you want to learn more physics, chemistry and mathematics starting from 8th standard till 12th standard, then you have to subscribe to my channel. Please do subscribe to my channel and stay tuned with my channel. Thank you.